Hello Algebra 1 students, here we are in Unit 6, Tier 3, Lesson 3, Solved by Elimination. Let's check off our booklets. Here we are in Lesson 3 of Tier 3, Solved by Elimination. There are two special cases when using the elimination method. The first is when there are no solutions, and the second is when there are infinite solutions, meaning many, or can't count because there's so many. So let's first look at an example where there's no solutions. So looking at this and we want to use elimination, remember that we have the two requirements, that it has to be in standard form and it has to have the coefficient with a variable that has opposite signs. And I have both of them are in standard form, but I do not have the opposite signs and the same coefficient. But looking at this, I know that 4 is a multiple of 12, and I also know that 6 is a multiple of 12. To get 6 to 12, all I have to do is times 2, and to get 4 to 12, all I have to do is times 3. So looking at this, I know that I need it to be opposite signs, and the x coefficients are both positive. So that means one of these two are going to have to be negative. So I'm going to just make the top one negative. So I'm going to multiply the 4 by a negative 3. So let's get in here and get after it. So this is going to be equation 1 and equation 2. And I'm going to multiply equation 1 by negative 3. Then I'm going to multiply equation 2 just by 2. And remember, you have to distribute these to each term. So my new equation 1 is going to be negative 3 times 4x, which gives me negative 12x. Negative 3 times negative 6y, which is going to give me a positive 18y. And then negative 3 times negative 5, which is going to give me a positive 15. When I distribute 2 to each term of equation 2, I get 2 times 6x, which gives me 12x. 2 times negative 9y, which gives me negative 18y. And then 2 times 2, which gives me 4. Now that I have two coefficients that are the same with the same variable that have opposite signs, I can apply elimination by adding the equations together. Negative 12x plus 12x is just 0. Positive 18y minus 18y is just 0. And then 15 plus 4 is 19. So we get an equation that is 0 equals 19. Well, we know that is not a true situation. 0 does not equal 19. So we can say, because when we tried to use elimination, and when we did, we eliminated both variables, and then what was left was not a true statement. This is when a system has no solutions. All right, let's go look at the other example. When we have infinite solutions, I want to assign equation 1 and equation 2. Looking at these, the first thing that I notice is that I want to get rid of the fraction on the bottom. But if you look, that fraction is positive. And to get rid of that fraction, I need to multiply it by a negative because I want the x on the bottom to be a negative because the x on the top is a positive. So let's multiply it by a negative denominator. So we are going to scale this by negative 2. That's what we're doing. We're scaling. Our good friend, the distributive property. And our new equation 2 is going to be negative 2 times 3 over 2x, which is going to give us negative 3x. And then we're going to have negative 2 times positive 2y, which is going to give us minus 4y. And then negative 2 times negative 3, which is going to give us positive 6. Now, if you notice, by doing that, I don't have to scale the second equation because now I have positive 3x here in equation 1. And then down here, I have negative 3x in equation 2. So I'm just going to move equation 1 down here, and then I'm going to apply the elimination method by adding both equations together. Well, 3x plus negative 3x is 0, 4y minus 4y is 0, and negative 6 plus 6 is 0. So I get 0 equals 0, and this is a true statement. So whenever you're using the elimination method and your elimination, when applied, eliminates all the variables and you have a false statement, there are no solutions. But when you have a true statement, there are infinite solutions. And that basically means that they're the same line. Good luck on your practice sets.